Follow the reasons. Angles must balance. Proof links facts.
Dawn and the Dew Hedge. This is Vesper, an orb weaver spider, waiting at the center of her morning web. You and I can see the complex beauty of the structure, but how do we actually know the mathematical rules that govern it are true? Vesper spins her silk in straight lines. In geometry, straight lines make strict promises. They follow fixed, unbreakable rules whenever they cross, run side by side, or cut each other perfectly in half. As Vesper moves outward along her strands, we can build these rules ourselves, stacking one logical step on top of another. That is the essence of a mathematical proof. It is simply a chain of clear reasons, linking basic facts to the precise spatial relationships all around us. Look right here, where two straight silk strands cross. Watch as Vesper steps over the center. Of the four angles created by this intersection, this top one measures exactly 130 degrees. Angles sitting next to each other on a straight strand form a linear pair. That means they must add up to exactly 180 degrees. To find this neighbor, we subtract 130 from 180. The angle right next to it settles at 50 degrees. We can apply that exact same straight line rule to the other side of the intersection. 180 minus 50 leaves 130 degrees for the next angle over. The pattern locks into symmetry. The four angles are 130, 50, 130, and 50. Opposite angles, what geometry calls vertical angles, always match. They are forced to be equal because they share the exact same straight line neighbor to reach 180. Now look at this section, showing two parallel silk threads cut by a diagonal strand, a transversal. As Vesper drops down the drag line, notice the top inside angle glows at 65 degrees. Because the parallel threads never tilt toward each other, that single transversal strand meets both of them at the exact same slant. That identical slant guarantees a perfect copy below. The alternate interior angle, the one on the opposite side of the transversal at the lower crossing, is forced to be precisely 65 degrees as well. And we can bring back our straight line rule to calculate the neighbor on the same side. They must form a 180-degree pair, so 180 minus 65 equals 115 degrees. Parallel lines maintain consistent measurements across space. Prove the angle at one crossing, and you can accurately map the intersections anywhere along their infinite path. Let's build a shape. We start with a straight baseline silk strand, anchored at points A and B, stretching exactly 8 units across. A vertical strand drops perfectly down the middle, crossing at a right angle. This is the perpendicular bisector. It cuts that 8-unit baseline exactly in half, defining two distinct sides, 4 units on the left and 4 on the right. Vesper walks up the vertical strand to a glowing dewdrop, point P, resting exactly 3 units above the midpoint. Watch the two new guy lines stretch from P down to anchors A and B. On the left, we formed a right triangle with legs of 3 and 4. Using the Pythagorean theorem, 3 squared plus 4 squared equals 25. The square root of 25 gives us a hypotenuse length of 5 for the guy line to anchor A. Now look at the right triangle. It is built from the exact same dimensions, a base of 4 and a height of 3. The math perfectly mirrors the left side, so the hypotenuse to anchor B must also measure 5. Any point on a perpendicular bisector creates two mirrored right triangles. Because those internal dimensions are identical, every single point on that bisecting line is forced to be equidistant from both endpoints. Vesper the spider climbs back to the hub. The structure is complete, holding steady in the morning light. Look at the image we've built, where every measurement earned its place. Crossing strands guarantee equal opposite angles. Parallel threads guarantee equal alternate angles. And perpendicular bisectors guarantee equal distances. Geometry operates as a rigorous method, the constant practice of providing a clear, logical reason for every single step. Test the method yourself. If you see two isolated crossing strands, and one angle is 72 degrees, what is the measurement of the angle right next to it? They share a straight line, so 180 minus 72 gives you exactly 108 degrees. Every straight line keeps its mathematical promise. Once you know how to link those reasons together, you hold the blueprint to construct and verify the rules of the universe yourself.
Vertical angles match. Linear pairs sum. Parallel lines transfer angles.